So today's date is Wednesday, February 3rd, and today we're going through the 6.4 notes from Michigan Virtual that are called Solving Polynomials. So if you read through Michigan Virtual's lesson either first or after, at some point after we go through this, you can see what things I cover. I'm going to really just kind of do an overview that are very similar to what you see with Michigan Virtual's lesson. So they start off with this scenario of this cardboard box. And if you've been hopefully reading through the lessons since 6.1, they've been introducing this box all around. And so today's, or for 6.4 lesson, they kind of start with the same thing, that you have this 3D box, or like basically imagine like an Amazon box that just came and has the following measurements. And so what we're going to do is kind of use this first example to help us solve polynomials. And so what's nice is up until today, like what we mostly did with 6.3, it's all kind of building upon each other. We first started off learning about synthetic division and long division, and then we used that information to learn about the factor and remainder theorems, and then just yesterday, or for 6.3, we had just learned how to use synthetic division, but also using that rational roots theorem to help us then factor it, to write it in factored form. But then today, now we take it one step further and we solve them. Similar to what we did actually, what we could have done yesterday or with 6.3, when we did factor them, we could have taken a step further and then just solved them if we wanted to. So that's kind of the idea here. So the main idea with solving polynomials is that we are still using, so we will use the following. Synthetic division. We can use, we're going to use the rational root theorem. That's what we saw in 6.3. We can, of course, still use the factor theorem, which we kind of were using already when we were working with synthetic division and seeing that when your remainder equals 0, you have a factor, which will then help us find our zeros. We also will need our older methods of factoring. So factoring quadratics. When you think back to the x squared ones from first semester, we did that even in 6.3. And finally, you might need to use quadratic formula today. Well, you definitely will need it. Those are kind of the things that will come up here. Now, the graphing calculator can still be used as a tool kind of throughout this lesson as well. Even when you get to the quiz, you can still use it. So we're going to start off with that first example, which is that cardboard box. So I'm going to write the question first, and it is definitely a long example, but hopefully by looking at the answer choices, we'll be able to kind of narrow it down. So we have, let's say, 12-inch by 15-inch piece of cardboard. Has squares cut out. And I can draw like a little sketch of this if it would help too. So it has squares cut out of the corners and is folded up to make an open top box, like basically where it's not covered from the top of it. So it is folded up to make an open top box. If the volume of the box is to be 140 cubic inches, what should the length of the side of the cutout squares, corner squares, be? I'm just going to write length of side of corner squares, just so it explains further with Michigan Virtual saying that they're called cutout corner squares, kind of what we mentioned up here, but just to kind of save some time and not have to write so much, we can kind of just skip to this. Okay, so we are going to find how we would work through this. So again, if it helps you, draw a sketch of, basically you have this like rectangle box that's a 12 by 15. So here's my 12 by 15. This side would be 12. And then this whole thing is, I'm sorry, I'll do it the other way. 15 is the longer side and 12 is the shorter side. So what it's saying here is that it's cutting out these corners in a shape of a square for each 4 of the corners. And when you do that, then we know that we don't know this measurement, so we're going to call it x. So x in every direction there. And then I'm going to go ahead and just put these little dots so you can just connect through each of that diagram. You can make this bigger also. I know it's a little small. I can zoom that in so you can see it a little bit better. But basically what we're trying to find is x. What is the measurement for x, which is the side length of the square that's being cut out of each of these corners. So to help me do that, I have to write an equation and solve it. So if I think of the whole measurement here, the whole thing here is 15. But once I cut out these squares, I no longer have that part. So I need to subtract from 15 an x length here and another x length. So technically for this entire part that I'm going to have once I cut out the box, I would have 15 minus 2x. That's going to be one of the dimensions of the longer side of the rectangle. And then do the same thing for the 12. The whole thing is 12, but if I cut out corners of x and x, then I would have 12 minus 2x. And then volume is always length times width times height. And we don't know what the height is here. If I was to cut these corners out, x would be the height because I would fold them in and that would create that open top. So like if you imagine taking like a 3D box, that's essentially what we're doing here. So I have an x also in front because I have length times width times height. All has to equal 140. So now we're getting ready to solve this, and the hardest part of this, or the part that involves the most work here, is now being able to like FOIL this and then kind of take it from there. So first of all, the x I'm going to kind of just leave in front there, and we're going to multiply this through. 15 times 12 is 180. You're going to get a middle term and an outer term. So this would be a negative 24x, and the outer term is a negative 30x. And finally, the last term is 4x squared, because negative 2x times a negative 2x. That whole thing is still equal to 140. I want to distribute the x to everything, but I also want to move stuff around. So I'm going to move the 4x squared first, and when I multiply it times an x, I'm going to get 4x cubed. Then I'm going to combine these x's, so this would be a negative 54x, but again, I'm going to multiply it by x, so I get an x squared. And finally, I have this 180, but again, I'm going to multiply it times x, so I'll get 180x, and then I'm going to subtract that 140 also to the other side, so that I just have 0 on one side equaling all this. And so now we're getting ready to figure out like how we're going to solve for x. Here's where you could use your answer choices that are given in the quiz. They'll give you a few of the options and you can kind of narrow it down that way. But to really go through the problem from beginning to end, we would technically use you would have to use the rational root theorem. Before we do that though, I can divide everything by 2 because that would make this a little bit more simplified. So 2x cubed minus 27x squared plus 90x minus 70 equals 0. And at this point, now I'm working with smaller numbers. They're still pretty large, but at least they're small enough now that I could use the rational root theorem, which remember was P over Q. It's plus or minus, but here's a nice hint on this one. Because we're working with x as a length, I actually am not going to have any of the minuses. No negative lengths are possible. And then also, if you think about what x could be, if you think about like how much the length here or this width is 12. If x happens to be 6, then I would have 6 and 6, and that would equal 12, and I'd have nothing left over. So I need to pick a number for x that would be less than 6. So those are my two criteria here. I need to make sure some number is my x is less than 6, and I need to also not pick no negatives. X can't be negative because I can't have a negative length. So that helps me narrow some things down because as I go to write down my factors here, First of all, for 70, I would have 1, 2, 5, let's see, 5 and 14 would work too. So 5 and then 7, 10, 14, 35, and 70. I believe that's all of them, but if I miss something, we'll hopefully catch it. And then 1 and 2 would only be my, for the first terms for the leading coefficient. So now we're going to divide all of these, but again, you can ignore anything that would be anything bigger than 6, and we can't have any negatives. So right away, we're not going to do the plus and minus, we're just going to keep the positives. But I can go ahead and start by writing 1 is possible, 2 and 5 are the only whole numbers that you're going to get, nothing bigger than 5 there. And then for when I start dividing it by 2, because so far I did 1 divided by 1, 2 divided by 1, and 5 divided by 1, I can do 1/2. I can do 2 over 2 would still be 1, and I can do 5/2 or 7/2. That's 3.5, so I'm still okay. I want to stay less than 6. 10 divided by 2 is 5, we already had that, and 14 divided by 2, now you get into numbers bigger than 6. So that's why it's not bad here. We have to pick from, it could be any of these possible answers. And so if I look at my answer choices, that'll be a good way to help you then decide what it could possibly be. Now, everything, of course, doesn't show up because these answers are rationals roots, and sometimes our answer can be irrational as well. And when we're dealing with irrational numbers, that's what we're going to see today a little bit more. So first thing I have to do here is figure out which one it could be. Now, I've already done this problem before, so I don't want to take up too much time doing synthetic division like a bunch of times. So I know that this is the root that will work, because if you also look at your answer choices, 3.5, which is 7/2, is probably going to be one of your answer choices. So that's how you can kind of start by narrowing it down, that let's check 7/2 with synthetic division. So 7/2 with this original, you can use the one equation that we did after we divided by 2. So it's a little bit smaller numbers. So we have 2, negative 27, 90, positive 180. And, nope, sorry, I mixed that up. That was not right. 2, negative 27, 90, and then finally negative 70. And then let's go ahead and get started here. Bring down the 2. 2 times 7/2 would be 7. And then when I add that straight down, I get negative 20. Negative 20 times 7/2 would be 70, or negative 70. 90 minus 70 is 20. And then 20 times 7/2 would be 70, which comes out to 0. That's my remainder. So again, I knew that I started there. I know that some of you won't see that right away and might wonder, why didn't I check everything else first? Well, that had to do with your answer choices. If you see that your answer choice has one of these numbers, start there, right? Don't bother with the rest of them because they may or may not work. And so clearly here, 7/2 did. So far, I know that one of my answers is 3.5 or 7/2, whichever way you choose to write that. But that's not my only answer. So let's find the rest of the answer. And so that's by writing this now as a quadratic, because I have now as factored form x minus 3/2, or 3.5, and then 2x squared minus 20x plus 20. Okay, this is what my factored form looks like so far. I can factor this guy here. First, I noticed they all they're divisible by 2. So I'm going to go ahead and divide them all by 2 and factor the 2 in front. So 2x minus 3.5, and now I have x squared minus 10x plus 10. So it's getting a little bit better, easier to solve, hopefully. I want to distribute this 2 in here so that I don't have this decimal sitting here. 2x minus 2 times 3.5 is 7. So now that looks a little bit better. 2x minus 7. And now for this part of it, which I didn't have to do this, but for this part, I could try to factor it, but I will tell you here that this does not factor. So I already tried to factor it because no two numbers multiply to get me 10 that also get me negative 10. So I have to use quadratic formula now. And hopefully you remember how to do quadratic formula. Here it is. So it's x equals positive 10, because we would always switch the sign for negative b, plus or minus square root b squared would be a negative 10 squared minus 4 times 1 times 10, because that's 4ac, all over 2a. And since a is just a 1, it's really just 2. And then we are simplifying this until we get to another answer so that we can have more than one possible answer here, because when we're working with possibilities for x, it doesn't mean that 3.5 is the only possible answer. Let's see what happens here. So when I simplify here, I get 10 divided by 2, I'll just go ahead and write that as a 5, plus or minus. This inside of that square root, it'd be 100 minus 40, which is going to come out to square root of 60. And that still is divided by 2. Now 60 has a perfect square sitting inside of it. It can be simplified. So I would write that instead as 5 plus or minus square root of 4 would be 2. So 2 root 15 is what I would get for square root of 60. And I still have to divide that by 2, but the 2's would cancel. And we're almost done here. We have 5 plus the square root of 15 and 5 minus the square root of 15. And here's where you would grab a calculator and check which one of those numbers. If it's a negative number, then that won't work. And if it's a number less than 6, or I'm sorry, greater than 6, it also won't work. So you want to check 5 plus square root of 15. That comes out to almost 9, so that's not going to work. I don't want the plus answer. I want to check, does 5 minus the square root of 15 work? And yes, it does. It's about 1.127 when I round it. So 5 minus square root of 15, or I can round that to about 1.127. I'll write that here actually because it's hard to see there. 1 point, actually rounded. So I got my two answers here. 3.5 worked, and now I also saw the x was approximately 1.127. Now I did have to round that one because it was an irrational number, and that's why I didn't see it up here in my rational roots when I checked it, because it was an irrational root. But you still want to include it because that's part of the solution. So your final answer would be 3.5 inches. So let me add the word inches after it, and 1.127 inches. So definitely a long problem here, but follow these steps so that hopefully you can figure out how to do that as well. So the Michigan Virtual Quiz for 6.4 that you're going to take will have the problem we just saw with the cardboard box, and then you'll have like probably 7 other problems where you are either solving the polynomials by finding it'll say something like find the x-intercepts, find all of the x-intercepts of the solution, or solve or find all the solutions, something like that. And so if a question is in standard form, that means it's already going from the highest exponent down to the number all by itself, then it's in the right form. If it's not already there, sometimes you have to do work to get it there. So we're going to go ahead and practice that, but your steps will always be the same, which is start with the rational root theorem, and then once you've narrowed it down, now because it's a multiple choice quiz, I would use that in your favor and go ahead and just use those options that are there to check using synthetic division. So there's no point in checking all of the roots based on, I know that's how Michigan Virtual explains it in their lesson, but to spend that time doing that would be a lot of work. When you already have a multiple choice test or a quiz, you can just use the choices from there and kind of narrow it down that way. So like if your answer choices have a positive 1 and a negative 1 for a different one, you can try starting with 1 and see if synthetic division will work and give you a remainder of 0. That's the the factor theorem, if you think back to last week. When we get a factor theorem and remember that the remainder equals 0, then we know it can be a factor and it can be written like in parentheses, and therefore find that solution of it after that. So we'll practice maybe 1 or 2 of these. I don't want to spend too much time on this, so I'll show you what one example could look like. After you do this though, and you get one of the factors, let's say, to work, you may need to do this again using, again, the answer choices that are provided, use the rational root theorem to, or use the different possible roots to help you use synthetic division for a second time if you need to, and then finally you can get to a point where you can find all the zeros. Now there are a few questions that you'll need to use quadratic formula because the answers have been written as complex numbers. That means they've been written, as irrational numbers. So if you see an irrational number, that means it's like the square root of 15, just like we actually saw in this example. This was an example of when you get square root of 15 for this, we know that it was an irrational number, not a rational root, but an irrational root, which you're not going to find on when you do your rational root theorem. All right, so let's go ahead and try one example together, and then we might stop here. And then if you want additional practice, there's a lot more that you can practice with the examples that Michigan Virtual gives as well. So for this example, let's say it'll say something like find the x, well actually let's do find all solutions to, and then here's the question. Let's do 3x to the fourth minus 10x cubed minus 24x squared minus 6x, and then let's set it equal to a negative 5. Okay, so you have to look at the question carefully. This is kind of tricky, and there's one like this even on the quiz where it kind of, you want to start right away. I know a lot of people will just jump right in and start doing the rational root theorem, but here's the catch. If you see a number that's out at the end of an equal sign, like all by itself, we actually have to move that number over first. So you have to deal with that negative 5. Once we have that negative 5 moved out of there, then we are ready to start working with the rational root theorem. So go ahead and add 5 so that we have our new equation. It is now in standard form, and now we can work with this. So 3x to the fourth minus 10x cubed minus 24x squared minus 6x, and now a plus 5 equals 0. So this is now my polynomial that I want to now use the rational root theorem for. So my roots are, remember, based off the leading coefficient, that's q, and the factors from 5, which is the constant. So for 5, that's my p. Remember, it's plus or minus p over q. So we would get 1 or 5 are the only factors of 5, and 1 and 3 are the only factors of 3. And then we just want to do plus or minus with them. So we get plus or minus 1, of course, and plus or minus 5. Then we want to take each of these numbers and divide them by 3. So 1/3, plus or minus 1/3, and plus or minus 5/3. So really not too many this time, but again, it'll vary from question to question. Sometimes there'll be a ton of them, and sometimes not as many. So now here's where I would look at your answer choices and try to narrow it down. So on your multiple choice quiz, you would then see the choices that it could possibly be. So I know from the one that I was looking at, one of the examples, I saw a negative 1 for one answer, but a positive 1. So I don't know which one it might be, but I think it might be one of them. So what I did was I started off with a positive 1 because I didn't know which one, so I just checked it. So I would do synthetic division here with a positive 1 just to start. If I get 0 for my remainder, then I know I have, a root, and I can kind of keep going from there. Let's see what happens here. So we have 3, negative 10, negative 24, negative 6, and 5. Bring down the 3. So we have 1 times 3 is 3. Bring down, adding those numbers together, you get negative 7. Negative 7 times 1 is negative 7 still, and this is negative 31. Negative 31 times itself still, or times 1 is still negative 31, and then this is negative 37. This doesn't look like it's headed in the right direction. So if that's where you can tell it's not going to work, you can stop right there. I'm going to go ahead and just write the last step, but you can see it's definitely not 0. Okay, so that's not going to work. So 1 is not a root. We can move on. You could try either 5 next. I try to avoid the fractions if I can, but again, it'll be based on your answer choices. Sometimes you may have to check the fractions. So let me try negative 1 though. If negative 1 doesn't work, then maybe we can try either the fractions or positive or negative 5. So same thing. You're just using the exact same numbers, but I changed the 1 to a negative 1. Bring down the 3. This would be negative 3, which is then negative 13. Then a positive 13 once I multiply it times negative 1. which gets me to negative 11, making that now a positive 11 because it's multiplying by negative 1 gives me 5. Positive 5 times negative 1 is a negative 5, and I do get 0 for my remainder. So because of that, I know now that x plus 1 is a factor. That's using the factor theorem because my remainder equaled 0. And then we're getting closer to being done. We got part of our factor. Here's what I know so far, that x plus 1, and then now this is 3x cubed minus 13x squared minus 11x plus 5, and that's it for that parentheses. So we have a little more work to do. So you would look at your answer choices again. Now that you know that it's negative 1 is an answer, or that x plus 1 is a factor, you could also just say x equals negative 1 is a root or a solution. I want to find all of them though. So the answer choices might include up to 4 possible answers for the roots. And so I would then check another one. So again, for the sake of time, I'll tell you one more that ends up working, which is 5. Instead of trying out all the examples and seeing which ones don't work, let's try to save our time. And so I know 5 will work here. Let's go ahead and check it though. 3, negative 13, negative 11, and 5. I'm using the numbers straight from what I finished off synthetic division the first time with. And then let's finish this up by bringing the 3 down. We get 3 times 5 is 15. Add those together and you get 2. 2 times 5 is 10. Add those together and you get negative 1. Negative 1 times 5 is a negative 5, and you do get 0, like we expected for the remainder. So this time, I can either say that x equals 5 is a solution, or an x-intercept, and also if I want to write it in factored form, that would be x minus 5 in factored form. So remember, you only switch the sign when you write it in parentheses. Just keep the number the same for whatever is there for synthetic, or for the synthetic division should be the same as the solution. So I'm getting closer. I have 2 out of the 4 solutions, and now let's see what we have left. So we have x plus 1, x minus 5, and then we have our last parentheses here, last factor is 3x squared plus 2x minus 1. Now at this point, you would try to factor what's that trinomial here, this quadratic. If it factors, great, then we're done. If it does not factor, you have to then use quadratic formula. And so again, it's hard to know what will end up happening, but this one does factor because you're thinking of 2 numbers that would fit. So you have your 3x and your x here to get to 3x squared. And then you know that 1 are the only possible answers here are 1 and 1 because they have to multiply to give me negative 1. But I have to pick my signs so that I get a positive 2 for my middle term, positive 2x. So I would make this a positive because when I go to do 3x times 1, I want a positive 3x and I want to subtract a 1x. That's how I get to 2x. And then the other 2 factors, I'm just going to rewrite them. X plus 1, x minus 5, and then the other ones are rewritten. Now, when we're solving here, because these are the factors, this is factored form or intercept form, I now want to solve them and find out what my actual zeros or solutions are. So it would just be switching all of these signs. If you need to solve this one, though, 3x minus 1, and set it equal to 0 to solve, you can do that. You are going to get a fraction here. So it comes out to 1/3, positive 1/3. So we have 1/3, we had a negative 1, a positive 5, and then you would also get another negative 1. So it's okay if something repeats itself like that, but that would be our final answer. So you would look for that choice on that quiz. Okay, so again, you have many examples or many problems on the quiz that are really very similar. So again, for all of them, make sure you're always moving everything over to one side by subtracting or adding to move everything to one side. Then go ahead and start with your rational root theorem, move on to synthetic division, find your factors, ones that give you a remainder of 0, or find your solutions until you have all the solutions that could possibly be there, but use your answer choices to help you here. All right, so that's pretty much it. I'm not going to keep you kind of go through any more examples because just going over these 2 takes like half an hour. So I'm going to stop there, but please consider going through the Michigan virtual lesson first and then take that quiz today if you can. And then if you have any questions, send me an email and I can always hop onto Zoom if you have any questions. Have a great day, and I will see you either Thursday or Friday, depending on your hour. I'm sorry, I'll see you on Friday since you have fifth or sixth hour.